Okay, so in this video here we're going to have a look at exponential differentiation. So if we look at our first question, pretty straightforward. It's e to the power of x, and our log tables tell us that if we differentiate e to the power of x, my answer just stays as is. So if we have a question that says y is equal to e to the power of x, find dy dx, our answer will just read as is. There's no change when we differentiate that. If we look at question 2, a little bit different. So we just need to, essentially we're applying a chain rule. So my outside function is e to the power of 2x. And then we have my inside function, which is 2x. So our e part stays as is. And then chain rule tells us it's our two derivatives multiplied together. So we get 2e to the power of 2x, or the other way to approach this type of question is we have e to the power of 2x. We're going to take our power and bring it down. So we get dy dx is equal to 2e to the power of 2x. And that's it done. So slightly different approaches, but we'll get the same answer. Okay, so question 3 now. And we're going to get, we'll take our second approach here. It might be a little bit easier. So we have e to the power of 2x plus 1. And if I differentiate my power, then I'll end up with 2. So my answer there is 2e to the power of 2x plus 1. Or else if we want to use chain rule, we get u is equal to, and v is equal to 2x plus 1. du dv is equal to e to the power of 2x plus 1. And then v is equal to 2. So by nature of chain rule, we're going to multiply. We get e to the power of 2x plus 1 multiplied by 2, which will give me 2e to the power of 2x plus 1. That's question 3 done. Question 4 now, we see we have a trig function, so we had chain rule here. Again, we're going to have chain rule. So u is equal to e to the power of cos x, and v is equal to cos x. So du dv stays as is, and dv dx will give me minus sine x. So we get e to the power of cos x multiplied by minus sine of x, and we can just tidy up as minus sine x times e to the power of cos x. Or we can write it the other way, it's the same answer. And our last example, number 5, here we see we have product rule. So u is equal to 3x, v is equal to e to the power of x, du dx gives me 3, dv dx stays as e to the power of x, and product rule tells us it's u times dv dx plus v times du dx. So we'll just sub into the formula. So dy dx will be equal to u, which is 3x, times dv dx, which is e to the power of x, plus v, which is e to the power of x, times du dx, which is 3. And just some tidying up here. So if I'm looking at this, I see I have e to the power of x and e to the power of x common. So I can factorize by that. So I get e to the power of x times 3x plus 3. And we'll leave it at that. We're not going to simplify any further. And that's us done for 5 examples of exponential differentiation.